In this problem, we are given a small circuit diagram and we are asked to use voltage division to find the voltage across the 6 kilo ohm resistor positive at the top. Then we need to use the 6 kilo ohm from part A and voltage division to find the voltage across the 5 kilo ohm resistor. So to start this off, we are going to look at the voltage of our 6 kilo ohm resistor. To use voltage division, this needs to be in series. So we have to make our circuit in series for our resistors. We know that these two right ones are going to be added together since they are in series. So we are going to have a 12 kilo ohm resistor here. Now, since our 6 kilo ohm and our 12 kilo ohm resistor are in parallel, we have to use the parallel formula to make them one resistor. So we're going to have 1 over 6 plus 1 over 12, and this is being raised to the negative first power. We're going to get that this is equal to 4. So when we redraw our resistor, we're going to have an 8 kilo ohm resistor and a 4 kilo ohm resistor. It's in series, so now we can properly use voltage division. This is our voltage divider formula. This is provided in the notes linked below. And we have our V1, which in this case is going to be our 6 kilo ohms voltage. And then we have our R1, which is going to be our 6 kilo ohms. We also have this VS that I almost forgot about, and our VS is our initial voltage, which is 18 volts. It's the voltage of our system. And next we have our R1 plus our R2. This is going to be our 8 kilo ohms plus our 4 kilo ohms, which is 12 kilo ohms. From here we can cancel out the 12 kilo ohms, and before putting this into a calculator, realize I made a mistake right here. This should not be 6 kilo ohms, this should actually be 4 kilo ohms, because our R1 is right here as it is right here. I was accidentally looking at this one up here. My apologies. But once we have all those, we can just look at this and cancel out our 4 with this 12. We're going to get a 3 down here. We'll cancel out this 3 with our 18, and that leaves us with 6 volts. So 6 is our answer for part A. Now we're going to delve into part B, where we need to find the voltage of our 5 kilo ohm resistor. Well, when we look at this, we can now write in the new information that we have. We know that our voltage of our 6 kilo ohm resistor is equal to 6 volts. And we also know that this 5 kilo ohm resistor and this 7 kilo ohm resistor are 12 kilo ohms. And this 6 kilo ohm resistor and our new 12 kilo ohm resistor are in parallel. So this is 6 volts and this is 6 volts. Well, for our right side, we want to find the voltage specifically for our 5 kilo ohm resistor. Voltage is just resistance times current, and we know the current in a series of parallel resistors is the same throughout. So basically what I'm saying is that the current located in our 7 ohm and 5 ohm resistor here is exactly the same. So what we can do is take our combined resistor right here and our newfound voltage and get the current. We have the formula that our voltage is equal to our current times resistance. We can also rewrite this so that our voltage divided by our resistance is equal to our current. We know the voltage for our combined 12 kilo ohm resistor is 6 volts, so we're just going to have our I equal to 6 divided by 12 kilo ohms. And 1 kilo ohm is 1,000 ohms. So this is really 6 divided by 12,000. This is going to give us the answer that I is equal to 0.0005 amps. Now we have our current, which again is constant throughout our series resistors, and so we can plug this in to our voltage formula and say that our voltage of our 5 kilo ohm resistor is our current, which again is 0.005, times the resistance of this resistor, which is 5 kilo ohms. If we plug this into a calculator, we're going to get that our voltage is equal to 2.5 volts. And this is the answer for part B. That is how you do this problem. If you found this information helpful, consider leaving a like. If you want to see more problems like this, there will be a playlist in the description. And lastly, if you have any questions about the content covered in this video, leave them down below and we will get back to them as soon as we can.